What is up, everybody? We're back at it, solving another sweet problem from Geotech for the PE exam. This one has to do with the retaining wall. I'm going to kind of go through it hopefully quickly because it's a lengthy one. It's going to go past the, your typical 6 minute mark per problem, but that's okay. We'll do some good explaining here. A retaining wall is supporting a soil with the properties shown in the figure. Here are our properties. What is the total active resultant per unit width of wall? Alright, so if we bust out the SERM, which we're all going to do, right? You all have that. And I'm using, not chapter, what am I using? I'm using the 15th edition of the SERM. And what we're going to do is we got to look at this figure to help explain what these properties are. And I want to ingrain in your mind that if you ever see these kind of properties, you're going to go right to the Coulomb method. And that's the figure you want to look at is figure 37.2, Fig 37.2. And it's going to describe what these angles are and how they apply to this wall. So if you look at that, we know that this is actually the beta angle, okay? The angle of this, this fill on top. We know our height here from top to the hill. This angle here, which is the rake of the wall, okay, this is our lambda. And then we're given an angle of internal friction and an angle of external friction. That's delta. And we know density, okay? So now we've got all those nailed down. Now what the heck are we going to use? Well, we know that to solve for our resultant, we're going to use equation 37.4 out of the book. And what does that tell us? It tells us that RA is equal to 1/2 Ka gamma h squared. We know gamma, we know h, this is our h. We don't know Ka. And based on these properties, we have to solve for Ka, right? Because you're either going to solve for this using the Coulomb method or what's called the Rankine method. Rankine is a lot easier, but we're going to have to use Coulomb with the properties given. So let's go to the big nasty equation. That's equation 37.5, and I will do my best to write all this out. It's a big one, but it tells us that Ka is equal to sine squared times lambda plus phi, all divided by sine squared lambda times the sine of lambda minus delta, and all that multiplied by, this keeps going, multiplied by 1 plus the square root of this ugly equation, square root, boom, and that's going to be sine of phi plus delta times sine of phi minus beta divided by, and that's going to be sine of lambda minus delta. It just keeps going. Sine times lambda plus beta, and that whole thing squared. Okay, following along with me? So this is our big nasty equation. We know all of these properties. Now we're simply going to plug them all in. And I am definitely going to run out of space, so let's go ahead and shift some things around. Okay, there's our big nasty equation. Let's go ahead and plug all this stuff in. So based on the properties that we're given, I'm just going to start plugging this in. Let's see, I probably need to go up a little bit so we can see those, right? Here's our properties. So let's just start plugging it in. We know Ka is equal to sine squared times 90 plus 29 divided by sine squared of 90 times the sine of 90 minus delta was 16. And then we got to multiply this whole thing. I'm going to do a bracket like this. 1 plus square root of sine times 29 plus 16 times the sine of 29 minus 10 divided by sine of lambda was 90 minus 16 times sine of 90 plus 10. Holy crap. And don't forget that this whole thing is squared. Alright, I'm not going to waste your time calculating all this, but if you do calculate all that, I get an answer of, you plug in everything, I get an answer, the whole thing of 0.357. Boom. Now that we know that, we can plug in our Ka value back up to this guy and solve for it, right? So let's go ahead and do that. I'm going to do it right here. So Ra, our resultant, is equal to 1/2 times 0.357 times gamma, which was 125, right? 125. 125. Keep in mind that that's in pounds per cubic foot, and we need it in kips, right? Our height was 25 feet, and you square that. Plug all that into your calculator. I get an answer here of 13945.31, and of course that is in pounds, and you need it in kips. That's pounds per foot. We need kips per foot, and we're looking at basically 1 foot of wall, so that's why it's per foot. All right, so that's basically 13.9 kips per foot. That is our answer, and it looks to me like the closest answer, if we go back up here and look at the answer selections, A is 14, and our answer was 13.9. So the answer to this guy is A. Boom. All right, hope that helped you out. It was a lengthy one, but get familiar with those two different methods, the Coulomb and the Rankine. Go check it out, chapter 37 of the CERN. All right, see you next time.